Yeah, I hope you're enjoying it so far. I did enjoy Mike's session before as well, so thanks again to Mike. So I'm going to be talking about IdentityIQ and Bean Shell. I'm going to be talking a little bit about what actually Bean Shell is, and also I'll be discussing some best practices about usage and give you some tips and ideas about testing Bean Shell code out as well. So I'm going to start with an overview because I see some very strange ideas of what Bean Shell actually is and what it actually does. So I'm going to try and explain this, what Bean Shell is underneath. First of all, it's an interpreter. It's not a compiler, although it does do some compile-like functions. So when you first present a program to Bean Shell, it's in just plain text, and it needs to parse that, and it parses it into what's called an abstract syntax tree. So it's important to know this because it's the AST part which actually gives Bean Shell its speed. But before it actually gets there, it can take a bit of time to build. So you and me might only see it in a few hundred milliseconds or so, but that's quite a lot inside of computing terms. Underneath, the Bean Shell Overviews use something called Java CC. So if you're actually interested in building your own programming languages, that's one aspect of it. Java CC is a little bit old now, but there is a new fork of it. So if you do want to use it, it's a very fast way of parsing your text files, and you give it a grammar, and it'll be able to create an AST for you. So parsing is time consuming. So the bigger the rule, the longer it takes. And if you have rule libraries as well, they're parsed alongside of your rule. They're not parsed separately in another session once and it's done. They're actually brought into the same namespace as your rule. So be mindful of that. So if your rule is quite small, but uses large rule libraries, in theory, it will still take a long time to parse. But to mitigate that, IdentityIQ does cache the Bean Shell instance. It does it for a period of time. So that means that it will reuse the AST as much as it can, and then eventually it will discard the cache and then reparse it. So, so the key to the performance of Bean Shell is keeping that abstract syntax tree available to be reused. So I mentioned here that Bean Shell is heavily uses Java reflection. You could almost say that Bean Shell is just a Java reflection engine. So a lot of it ends up with Java code being executed, and Bean Shell itself is just orchestrating that for you. Now you can create your own methods and classes even inside Bean Shell, and they'll run as methods inside there, but ultimately you'll be executing some Java code. So the AST itself is built of a series of nodes. So underneath it, there's a node in like a tree, and each node tells Bean Shell what is expected to do. So you could have a node for try, catch, finally, or a node for a while loop or whatever, and then it will execute the code as it sees it with the parameters which is passed to it from when it's been interpreted. Variables and state are persisted in the Bean Shell namespace. So the Bean Shell namespace is key to actually how applications are persisted moving forward. So one of the things about that is because it's interpreted code written in Java, which is then reflectively using Java back, it won't be as fast as Java, and it isn't. But the performance is still very good, and the way that it's written is it's tries to expedite all the functions as fast as possible. But you'll probably find that the performance is still good enough because most of the time you'll be calling stuff which is I/O related. and it doesn't matter where you're going for that, it'll still be the same performance. So, you might be getting some objects from IdentityIQ or calling another library or maybe Active Directory or whatever from your Bean shell code. So that's tied really to I/O. So you won't notice too much of a difference, but you should watch out for large rule libraries. So as I mentioned, that a rule library is brought into your rule. So you've got these, you may have a small rule or whatever. If you bring in a large library, then that library has to be interpreted along with that rule before the AST is produced. So that first hit of actually producing the abstract syntax tree will get bigger. And please remember that Bean shell rules are cached only for a period of time, then it has to be destroyed and reinterpreted. So bearing that in mind, high iteration rules should be fine-tuned. So avoid big rule libraries in high iteration rules, like a correlation rule, for instance, or some aggregation rule, or somewhat. So it will hamper performance. So if you think about it, if you're iterating over hundreds of thousands of objects, and you add maybe 10 or even 100 milliseconds to the time of that because you've got a complex rule, then that could be long times, even possibly hours added to the actual overall aggregation. So make sure that your rules are fine-tuned. So we have in the past, for more complex stuff, moved it into Java. So that's usually a case of, we've got some rule libraries which are quite heavy going and it's needed across the board. So we could move it to Java, but Java's quite cumbersome in this environment because you have to go and deploy the actual classes and restart the server. And you can't update it without downtime, so it's a problem. So the fact that we have IdentityIQ plugins these days, and you can expose plugin classes to rules, then you kind of get the best of both worlds. So you can actually get, and I'll got a very short demonstration of this. But basically, you could put your libraries or your heavy duty code inside a plugin, and then you can deploy it just like rules. It's hot deployment, and then you can access it across your Bean shell landscape. Just to kind of show you this, I'll just dive in. So I'm just going to bring. I wrote this plugin. As you can see, it's very simple. All it does is it has a class called example, and I got a method called say hello, and hopefully it will say hello to us. And if I just go into IdentityIQ, and let's have a look at the rule. So here's the actual class package where I'm bringing from the plugin. I'm logging out to this logger, and so we can see the results in my log output. And then I'm logging at the error level, a particular statement. So I'll just quickly show you that I've got the plugin installed as well. Developer Day plugin. So I will run the code, and I'll just bring my logger over here. And I'll just get the name of the file again, which is the plugin. Right, okay, so we should see it being run now. So we can see that I've got a bean shell rule, which is just calling a class in my plugin. And there's the rule. So here I've imported that class from the plugin and then just log this out. So with that in mind, you should be able to, if there's a performance concern, or you're finding that managing large libraries inside of Bean Shell is starting to become cumbersome, then what you can do is you can move it over to Java if need be. But like I say, Bean Shell, for its purposes, it performs usually very well. But just be mindful of large amounts. So with the fact that it's an interpreter, there are a few things which Bean Shell doesn't do well. And some of the things that Java programmers take for granted that you shouldn't be doing inside of Bean Shell. So I'll just go through some of those, but from the best practices point of view, I'll just talk about logging. So I would strongly suggest you create your own logger for each of the rules. I would normally have the same kind of spacing, because I manage my logs in the same way. And you would want to do that as well. So I usually have it as the org and customer's name, then rules, and then the rule name. That allows me to actually target the package as well. So I can target org rules if I wanted to, and just turn debugging on for all of them. But definitely look at creating your own logger. It's up to you what you want to call it. Logger, rule log, lib log. I usually stick to log and just override what's there. Do make sure that you import the right library for that. And there's one of two libraries that you can bring in, and I'll show you the next one in a few minutes. But one of the things I see a lot in some code is setting the log level in actual code. So this I really can't stress how bad that is, because that's almost as bad as putting system.out.println in your code, because you'll forget about it. You'll do lots of work around it, and there'll be instances where this set log level is in there and you've forgotten because you just want to turn it on for debugging. So I would strongly suggest you get a tool to help you manage the logs and do the log level for you and so on. And again, I can talk a little bit about that at the end of this session, because there's lots of tools available for you to actually just turn that on and off. Infrequently, there are times where you're just using it because you're outputting something at the IQ console, and you're just using the log because it's convenient. That's okay. I'm not going to argue about that. But in your productive rules, don't set the log level. So the other thing as well is that if you've got an expression inside your debug command, it will get evaluated, right? And some evaluations are more expensive than others. So here I've got identity.toXML, which will get evaluated. Even if debug isn't actually enabled, 2XML will be evaluated. And 2XML is particularly resource hungry, because it will go and fully flesh out the identity object in this case, rehydrate it, and all the data, all the links and everything will be brought into the identity. And if you've got a big identity as well, it will take time. So if you're just logging that and you don't care because you turn debug off, you got it on error, you're still doing that effort. So be mindful of the fact that you're not shortcutting the 2XML there. So below, I've got log is debug enabled. That will shortcut this. So it will first check to see if debug is enabled before it's executing the debug statement. And then that means if debug isn't enabled, then 2XML is not going to get evaluated and executed. The thing I don't like about this is that it does make code more less tidy, more readable. There may be I may be able to give you a way around that to some degree, but ultimately, if you're doing this, then I would check to make sure that the debug is enabled first. So as I mentioned, checking for the debug enabled does add noise to the code, but here we're seeing that I've got two statements below. The second one is quite obvious. There's nothing being evaluated. You're just passing a string. So you could just debug that out, and it doesn't really matter. The first one, log.debug identity. Notice that there's no method being called off that. That means you're just passing an object reference, and nothing's going to get done with that apart from passing the reference unless the debug is actually turned on. So both of those are lightweight. But if I put identity.2XML, that becomes heavyweight, because then the Bean shell and Java will have to evaluate 2XML. So you can use a logging facade. So SL4J is bundled with IdentityIQ. And here you can use the facade to basically give a parameterized log debug entry. So you can see that I've got two squirrely brackets, identity object, test file. These two parameters are filled in by the objects which are passed later on. So identity and wobbler is being passed on in here into the actually log debug statement. And what that means is that you can put you can do string concatenation in effect without actually having the overhead of actually evaluating it. So that's a good aspect of SL4J when you're doing logging. Again, though, if I put identity.2XML there, then you've got the overhead of it being evaluating, and you would need to do a check to see the debug level is being enabled for your logger. So in effect, when you pass an object to it and it starts concatenating to in your string, in effect, it will do a two-string for you. So if the identity object has a two-string method, which gives you some useful information back, then that should be enough for you to get on with doing the work. So when you're querying objects, there are several different ways of pulling objects back down from IdentityIQ. One, you can end up using database cursors, or you end up getting objects directly. So I've got here, there's two types of queries that I'm doing at the top. Context.search and doing the identity class and passing a query options to it. And the second one is context.getObjects, identity class, and then query object. One returns an iterator, and one returns a list of objects. Now, believe it or not, they're both doing exactly the same thing. So when you're doing a context.search and you're just bringing the identity class and the query options across, then you're getting a list of objects come back, and they'll get hydrated into a list, and you get a list iterator, which is what you're iterating on. So if you're doing a search and you're bringing back 1,000 objects in your search, both the context.search identity class query option and the get objects will both use the Hibernate cache to store 1,000 objects for you to iterate over. So it's not particularly efficient. So I'd only advise you to use those two methods of getting objects for when you know that there's only a small and quantifiable number of objects that you're bringing back. And you want everything inside the identity object. If not, use a database cursor. So if you use context.search, identity class, query options, and a field list, which can be an array or a CSV value, then you get a database cursor coming back. Now, that's a lot more efficient as far as, just iterating through a set of results. And also, it could be, in theory, faster as well, because you're not having to rehydrate lots of things. You do get lazy initialization, which helps you when you do a guess objects. But even so, if you're just bringing back one or two fields, then it doesn't really matter. So I tend to try and use database cursors as much as possible. There is a pattern as well when you're doing this. So if I am bringing back a large number or an unknown number of objects, I would still use the context.search with the field list and just bring back the ID. And then I would then, while I'm in my loop, go and fetch the actual object using a get object by ID and then processing that. So best practices when updating an object. First of all, lock the object. If you should always lock the object before you update it. Otherwise, it ends up with weird, strange problems. But you do need to test exactly where you're doing this. So I'm saying here about the dcache. I'll get to that in a second. So when you're locking an object, you've got to be mindful about where your rule is going to be executing. And normally I would try and avoid updating objects as much as possible. And if I was going to update it, I would see if it was in my actual space in the first place. So if I've got an identity object already passed through in the rule, then I wouldn't attempt to lock it. I would use it and persist that in the actual rule. If you're getting lots of objects back, you've got a context.dcache, but again, you've got to be mindful of this. I'm recommending that you use context.dcache without an object passed to it. The reason for that is because you're not going to decache the children of that object. You're only going to decache the object. So let's say the identity. If you go and grab an identity and iterate through its links, or have a look at what roles it's got, or whatever, then when you do a decache and the identity object, you're just decaching the identity and not its children, and they will still live in the cache, and you may be wondering why you're getting cache flow. So I would recommend you use the context.dcache if you're doing that. And then you're absolutely expediting the Hibernate cache issue. So there's a paper on Compass about IdentityIQ 8.0, and when you've got a database cursor open, if you do an update and then a commit transaction, then you could end up with the database cursor closing for your next iterator and it blows up. So this is a Hibernate thing. This is Hibernate. The update to Hibernate actually did this. So we've got some ways of mitigating it. We've got a couple of new iterators, incremental object iterator and ID iterator. So you can use those. And I've got some example code. So if I get a chance to have a look at that, I'll look at that. In fact, I'll just stop and have a look at that now. And you can also use set clone results on the query options. So just to let you know what set clone results does, it actually copies the query into memory. Yeah, so if you do a query options, set clone results to true, and you start iterating it, the iterating process would, in effect, iterate all the actual records for you, put it into memory, and then return back the iterator or the persisted memory state of your query. So it's kind of expensive, but it does work. It's a simple way to work around it. And if you're getting small record sets, you shouldn't really notice that much of a difference. But there are two other iterators that you can do, and I particularly like the ID iterator because it's nice and lightweight. So I'll just show you a piece of code. Okay. So here we're doing a commit transaction, and we've got it on a database cursor. I know it's a database cursor because I'm doing the context.search, and I'm just bringing back the ID. So I'm iterating over the IDs here, and I'm trying to get an identity object. So the first time I do this, it will work. And then actually it will work until my record count becomes a modulus of 10, and I do a commit transaction. And this is where the weird problem happens. It will blow up, yeah, and it will complain about the fact that you don't actually have a cursor anymore, which is a shame. So, you know, and then to fix that, and here I'm suggesting using the incremental object iterator. Because I was just grabbing the ID, I do that with this one. So that's actually doing very similar work to this. It grabs the ID, and then I'm using that to do a get objects. So in effect, it's doing a very similar thing. Is that it's getting the IDs, and it's persisting those into memory and iterating those just to get the actual object. So the overhead's quite small because you're not persisting large objects at all, and you're still being able to iterate over the identities and being able to commit it. Okay. So when it comes to best practices, avoid using commit transaction in real hooks. And when I say commit transaction, I'm absolutely also including rollback transaction, which is actually a little bit worse. So, and the reason for that, in real hooks, you've got a process underneath which is doing some work for you. You know, if it's aggregation or certification or whatever, and it's got the same connection that you have. So if you do something like a commit transaction, then there's no way for it to roll back if there's a problem. And, you know, you may end up with some strange problems because of it. So in real hooks, I would suggest avoid using commit transaction. The actual process itself should do a commit transaction for you. Please test for it. Make sure that things are being committed as you'd expect. But like I say, usually the session will be committed for you. Another best practice I mentioned about Dcache. Dcache is absolutely your friend. So if you have a lot of high iteration objects, then you need to make sure that hypercache is not going to get exposed with that. So again, though, that can cause problems as a rule hook. but a lot of our rule hooks now are mitigating that. Expect somebody to do a decache, and we do reattach the objects. But like I say, you know, if you're actually going to do that, having a least effect on the cursor and the state of the objects as possible is really key for fast performance. The other thing as well is if you are actually querying for lots of objects in your rule, then are you actually doing the right thing? Could the query be a bit more fine-tuned to make sure that you only get the objects that you need? And there's various different ways. So we've got the cell point filters, which are quite powerful, and you can get to the objects and nail them down quite quickly. You've also got HQL to help you do the queries as well. I'd avoid using SQL. Only because it doesn't obey our object model. Our object model is object orientated, not relational, although it's put into a relational database. But yeah, I would try to make sure that the objects that you bring back are just the ones that you need to process, and work on your queries more rather than put it into high iteration and start filtering out objects. So better design may expedite the fact that you need to do lots of things with the Hibernate cache in the first place. As I mentioned as well, 2XML is very expensive. I'll avoid unless you need to. So there's a couple of things here which I put here as avoid side effects of logging. This isn't Hibernate. It's probably on the wrong slide. But avoiding side effects for logging is key. So if you're actually checking for a debug level or something like that, then don't write code in there that affects how your method works. Yeah, and you've also got to think about this, is that 2XML will do that to a point as well, because it might hydrate objects which normally it wasn't expecting to. So be wary of using 2XML, especially in logging, because it does have a side effect. And anything else inside your logging, make sure that it has no effect on the rest of the rule. It's the most bizarre thing. It works in dev, but it doesn't in production. I've had this a few times where we've actually looked back and trying to figure out why it was working in such a way, because in production we turn logging on and then it all works. And it was working expected. So you're scratching your head and you think, there's a side effect there. So make sure no side effects. And of course, avoid expensive evaluations. The other aspects of this is monitoring. So I use a number of techniques for monitoring. So cell point and log4j can be used quite a lot to track execution times. You can also use the cell point API meter, which is a really easy to use API just to meter code. So if you've got anything that you're really curious about and you want to meter it, and you get a nice rich UI for it in the debug pages, then use metering. Absolutely use metering. But like I say, the other thing you can do is use log4j. It's got timestamps in there, tells you what thread that what's coming and run on, so you'll be able to discern exactly how long a particular method is used to run. Okay. So I'm going to talk a little bit about testing, and I'll show you one of the tools that I use for testing. And there's one here that isn't listed, and I'll talk about that as well. So from a testing point of view, you can use IIQ console. IIQ console's got a run rule command, and you can supply parameters to it and such like via file. You've got the IdentityIQ debug page, which is useful for standalone rules, but it doesn't support arguments, so it's a bit more difficult to do that. There's some professional services tools. One of them is the JUnit helper. So what that actually does, it spins up IdentityIQ inside your IDE, and you can use JUnit, and that's fine. And I did a lot of work on it in the past. It gives you a nice little helper class to help you get things done quickly about inserting rules and finding out where problems were. But it's quite heavy, right? And it's slow because you have to spin up IdentityIQ. But it's really, you can use Java code and to actually do that. And as the name suggested, I use JUnit quite a lot there. There's also the DevStack plugin. That is an alternative to the IIQ console, which allows you to run a lot of the IIQ console commands plus enhanced rule debugging and so on. And I'll just show you that a little bit. We did have the IIQ DA, Developer Accelerator, which is a fantastic tool. It's currently out of production at the moment because there's some bugs which stop it working with our latest version of IdentityIQ. So we do have other alternatives. So I'll show you what I do from a DevStack point of view. So I'll just start it. So I'm connecting to my instance of IdentityIQ, and what I'm going to do is I'm going to run a rule. I'm going to purposely put an MPE in a rule. I really hate MPEs. Okay, so I think that one will work. So I can run a rule, and it's and yeah, I'll get an MPE. So there's an interesting thing here is that when you're actually running it from here, I'm getting an MPE. It doesn't actually tell you what line number it's in. If you noticed in IdentityIQ, it doesn't. And it's actually not a bug inside IdentityIQ. It's in Bean Shell. There's a patch for it on the Bean Shell website, which is for the next version. Funny enough. So yes, it will tell you the line number and everything, but that doesn't really give you that much. You can pass parameters and so on, but I can also add a debug command to it, and that works very well. I love demonstrations of stuff. So that gave me an MPE. So what I can do is I'll just go and grab one of my other rules. Let's see if this works. So yeah, so this rule also does an error, but because I've had the debug command, it gives me some additional information. It tells me what variables are instantiated in there, and basically does a toString on it, so you can see roughly what's inside the object. If you see query options, it actually gives you a nice piece of information. It will list me the methods or anything I've got it, and it'll also give me a full detail and a stat trace of the error. So I use that quite a lot. When I'm starting to get errors, I rarely get errors in. I always get errors in Bean Shell, so it's useful for that. Yes, you'll be able to get a lot of rich information from there. So these tools are available on the SailPoint website. So yeah, you can use the IIQ console as well. The only difference is you don't get the rich information that. So the JUnit helper, again, that you'll be able to wrap rules around in a JUnit framework. So DevStack and JUnit Helper also allows you to test methods. So, okay, so if we're talking about testing, then you've got to think about, is it testable? Yeah, so if you've got a rule which is a big, just one big glob of code, and you've got 10 use cases in that one common node, it's very difficult to test at all, and it's very hard to maintain it, and it's hard to debug it. So I would strongly suggest that instead of having 10 use cases in just one huge script, you have 10 methods which implement each use case. Have the methods in a way that you can call them and test each of the methods individually, atomically, yeah. And then you can test it. Then you can test those methods, right? So it might sound like a lot of work to do, to be able to go in and write a unit test for each method. But the reality is you're going to be doing that anyway, but manually, right? Because you're having to run it, see if the results are what you expect. You probably got logs in there, which is returning back variables that you're interested in. So if you do wrap it around in a test harness, then what that means is that in the future, if you come back and change it, instead of the fear of getting it wrong and going through a full barrage of tests and so on, and also trying to remember exactly what to test for, you've got it all written out and you just run it. And honestly, the first time you run, well, the second time you run the unit tests, and it's all automated, and you're there going, this does, I know this works. It's past everything that we thought of before. Then great, and you can relax. The only other thing I'd say about unit testing is that you only know what you know. So now and again, maybe something which you haven't thought about, or some customer's data has changed the way something works in a way you were not expecting to, and it blows up. So again, with unit testing, what I do with that is I just add that use case to the unit testing, make sure I reproduce it, and then fix the code. Because I've got a test case against it, and I don't need to keep on going back. I'm running possibly a complex procedure to go in and get that data back into the rule to see if it blows up again. So unit testing will absolutely expedite from it, especially in IdentityIQ, where usually your rules embedded in a workflow or a function somewhere, which you have to go through the UI and takes you a long time to get to, and is quite cumbersome to actually find. Okay. So and the other thing about DevStack is it's a remote tool, so you can actually test for your stuff remotely. So that if you can see IdentityIQ, you can test your rule. You don't need to have a database connection. You just need to see the browser, and it talks via REST. So it's quite lightweight and useful from that perspective. Okay, so I think I'm going to finish a little bit early. I knew I should have talked a lot slower, so thank you. I will be available on the developer relations website as well to answer all your I would try to answer all your questions about this. Please hit us up if you've got any queries, and yeah, I will make sure that I get a response to you as soon as possible.